Anubindya, sir.
Anubindya, sir. So students are live now. They can hear me.
Yes, sir.
Okay. All right, students. From the response last week, not just the question, and from our departmental faculty, this is very much clear that all of us enjoyed last week lecture by George sir very much. Not only because of the information or the knowledge, but the simple way through which it came to us, especially to you, honestly. So I think last week's some of the uh, topics was basically knowing air, and more importantly, how composition of air with moisture and other gases, how they're related, pressure, they're related with rain, desert formation. So today's talk will be continuation from that, and through his talk, we'll find out that we'll enter into the pollution part and how to control that. Like the other lectures, you'll have opportunity for asking questions. But I think you have noticed last week that because of some time strain, we couldn't take all the questions, but most of them we covered it. And I can remember there is one question which uh, Josh sir couldn't, he was very much happy to take it, but from our side, we couldn't just ask him. The reason was because of the time. So I would suggest you, you be ready with your question, and once the maybe throughout the lecture or once it is over, you can write. Remember, this is from all of you and we cannot connect. That is why if you think that your student is, your question is very basic, in case you want to ask later, we'll be happy to reach George sir later also with your question. Anyway, I'll not take much time. So George sir, thank you once again here, and so let's continue and let's learn something. Thank you, sir, to you.
Okay, thank you, Anubindya sir. Can you hear me?
Yes, sir.
Okay. So I think it is 4 plus. So good evening to all of you. Uh, Let me say since beginning, whenever what I have observed some people who are at collegiate level, they immediately jump to the topic we want to listen modeling, because that appears to be bit higher end and fascinating. It may fetch job or something. So they talk about modeling. But I know no college the subject is taught, air pollution per se, because it is highly interdisciplinary. So always I start from the basic. And as I understand from this VIT-AP, the students are of undergraduate level, and therefore my attempt is to give them the to create or build up the storyline so that at a later stage they should not make the mistake of creating some control devices. I'm frequently seeing this, and what I find that most of the uh, creators of inventors of air pollution control devices, they violate the basic laws of thermodynamics or mass control or mass conservation or energy conservation, because they feel control means there is some box in which you put something dirty, and if it comes out in a clearer fashion outside, then it is a control device. It is not so. One needs to know the basics of the subject, interdisciplinary subject, and therefore today also I am continuing with what I talked last time, and in the same line I'll be talking on issues. By the end of the this talk, you can only convey me whether you have something really to take home, because that shows the usefulness, utility of this 1.5 hours discussion. So my today's focus will be on air, environmental pollution, and risk assessment. There is a confusion. This release of gas from the methyl isocyanate tank of UCIL, was it an air pollution? Another question is, on 10th of June, not June, 10th of May, there was a release of styrene liquid from the tank in Visakhapatnam, and 12 people succumbed to the poisonous gases. Is it air pollution? So if you get to know these subjects very clearly, you will realize the boundary, where is risk and where is air pollution. So my talk today will be starting from atmosphere only, Earth only, but gradually coming to a point where we should be able to understand episode, environment pollution, and risk. All the three are different. So where we should put which means which kind of resource person we should put, that we need to know. When styrene gas was leaked, I was immediately called the same day. By night 10 o'clock, I was there at Vijayawada, this Visakhapatnam plant site, and the situation was very pathetic there. And I stayed there for almost 10 days, no fear of corona, and only issue was how to survive there, because there was panic. Some people died. So how to manage the situation, how to understand what is styrene. People living around were not knowing. So, and everyone was saying it is air pollution. It was not air pollution, it was an accident. So our knowledge at that point should have been on risk assessment part, that we are storing some hazardous chemical at a place. So how to deal with it? What a priori knowledge you should have. How the disaster management people, they were with us, our team were together. And when disaster management team comes, how they are going to deal with it? Because suddenly if you tell styrene gas is leaked, they searched the Google and found that nowhere in the world it has happened. It's for the first time in India. So we don't have any knowledge. And if we don't have any knowledge, how we will deal with it? And therefore, when such installations are created, what is done is its chemistry, its effect, everything is documented, and those who are responsible for emergency action, they are prepared for it. So my intention is to tell, please be careful about air pollution and environmental pollution are different subjects. There's no very sharp line, there's gray line. The general principles required to understand for both are same, but you should know which one is hitting where. So let me start my presentation today. I'll begin with my talk, and if time permits, then I'll go to ozone layer, which I did not do last time. Can you see this?
Yes, sir.
Yes, sir. So it's in slideshow mode.
It's in the slideshow mode.
It's in the slideshow mode. Okay. So some history of air pollution. Air pollution, is it a recent phenomena, or how long it is? And when we call it air pollution, because for our survival, we have to do some activity, so we cannot stop everything. So here we go, how air got polluted. Here is a container. Now, what I'm trying to explain here is mass and energy through a system. So here is a container. What two arrows are shown. So one arrow is the solar energy. The sunlight comes Here I have assumed that this container do not absorb heat. Okay, it doesn't absorb heat, and the entire solar energy is reflected back. This system we call isolated system. Here is another container which is not having a lid, and you can throw some stone or an object or precisely we can say a mass. So in the previous system, which is called an isolated system, it is trying to enter but is restrained and it is kept out. It's an isolated system. In the second container, the an object or a mass is brought in and it can enter inside because it doesn't have a closed system, it is an open system. Let us see this third system. In this case, the lid is transparent. So solar energy can come inside, a part will be absorbed and then a part will be leaving the system. So what is happening here is, if we can see in terms of solar energy, then short wavelength is coming and long wave radiation is leaving outside the system. So this is what is. So these are the three systems: isolated, open, and closed. Now, why I am trying to show this is to understand what is Earth. In among these three, which kind of system is Earth? So here it is. Here is Earth, lot of stars, sun. From sun ray, the solar insolation can enter inside our atmosphere. So we can say that as per this previous slide, it matches somewhat like open or closed system, because solar energy can enter, but see, mass cannot enter, and therefore it's a closed system. So what we say, Earth is a closed system. But if you can recall my last Saturday's talk, I stated that helium and hydrogen was there in the atmosphere in the early formation period, which is escaped because of its low atomic mass, and Earth's gravity could not hold it. It means matter can leave out of the system. Meteorites hit the Earth. Lunar Lake near Buldhana is an example. It means mass can enter. So you can say it's an open system. No, because release of hydrogen, helium from escape from the atmosphere or entry of a meteorite is a rare phenomenon. Occasionally it happens over a very long historical time scale, and therefore we say that our Earth is a closed system. Now, if it is a closed system, how it helps us to understand? Here it is. Exchange of mass and energy in space and time takes place within this Earth system. It is not with any other planet. So where we have to be careful, our resources are limited and waste cannot be thrown out of Earth's closed system, because we cannot throw anything out. Mass cannot be thrown out. And if it is so, we should know what are our limitations in terms of both resources and assimilation of waste, be it solid, liquid, or gas. So this is how we begin, why we should be careful about our Mother Earth. Now, if we go to the previous slide, resources are limited. So here we comes, what are the resources? And when resource exploitation started, who started this? Recently, you can see if you go for mining activities, say that, see, you are exploiting our resources. Sand excavation not permitted because it is changing the course of the river, or it is changing the natural regime of riverbed. So here I have few slides. Importance of heat was understood some 1.5 million years ago by Homo erectus. Bushfire due to natural lighting, partly charred animal flesh, cooked meat. This helped Homo erectus or the inhabitants at that time to understand if meat is put into a system which now we call fire, its taste is improved. It's easy to digest. So thereafter, the knowledge of the importance of heat and fire took place, and knowledge of fire came some 15,000 years ago. Even today, when we praise or pray the basic elements of our life and nature, fire is one of them. So you can understand how important fire is. Now, resource exploitation, when it started. So it starts with Stone Age, initially when stone tools were made for survival, then Bronze Age. Now, we need to understand why bronze, why not Iron Age. So here is it. The knowledge of use of copper and tin for agricultural implements and war weapons. Why? If you go for mining, copper, arsenic, tin, lead, silver, these materials are found together in the natural deposits. So from there, people at that time started melting and using those material for agricultural implements and war weapons. And the mixture of copper, tin, lately we say bronze. It is harder than copper because of its alloy with tin or other arsenic at that time. Bronze can be easily melted and easier to cast. It is harder than pure iron and they are resistant to corrosion. So it was a Bronze Age. People were happy with it. Later, it came Iron Age because they found that iron ore is abundantly available. Large part of exposed iron ore they got. So they started using iron ore. Now we are gradually shifting to the point where exploitation which causes pollution has come, air pollution. I am coming to that point. Metal extraction using heat and reduced environment created by carbon and carbon monoxide. Now, iron ore is, you can see in the chemical reaction, this is iron oxide, Fe2O3. If carbon is added, carbon is having more affinity with oxygen compared to iron. So it releases CO2, which is a gas that can be released. We'll get iron. Besides, carbon, if burnt, so at higher or along with fire, this carbon releases heat. Heat causes melting of Fe2O3, melting of iron, which we can cast into the desired shape. So now you see there are two things. One is the presence of carbon. Second is the energy contained in carbon or the energy released when carbon reacts. That's what is required for us. So heat and carbon, these two things were realized during Iron Age, not in a scientific manner, but by experiments. Now, what is the source of carbon? At that time, it was actually when they were trying to use iron ore, it was wood and charcoal as a source of carbon. What is charcoal? You burn wood and partially burn it so that the off gases are removed, and then it's a concentrated carbon form. So wood and charcoal. Thereafter, they found large deposits of carbon, and that was called coal. So coal as a source of carbon, it was called sea coal because it was found near seashore in Scotland. So a carboniferous strata exposed on the seashore in Scotland and northeast England. So this was the first coal mining at that time, for official coal mining, from where they started extracting coal for use of reduction of iron oxide. Now gradually we are coming to the point where coal use is important. So sea coal was used by artisans for lime burning, metal working, smelting during 13th century in England. Students just need to read this, you will come to know sequentially, one by one. Now, see the point number 11. The visible smoke from widespread use of sea coal made it clear that coal smoke is detrimental to health. It was assumed then. Just like today, the stubble burning in Punjab, Haryana is releasing smoke, black, white. One need not go for study. When in 13th century it was, 14th century it was known, even today we should be able to get to it and understand this, which led to unrest and agitation in London. As a fallout of this, the Royal Proclamation was issued in 1306. So now you try to understand the first law on prevention of air pollution was in 1306, prohibiting artificers of London from using sea coal in their furnaces and commanding them to return to traditional fuels, that is wood and charcoal. But if you use wood and charcoal to a large amount, the pollution may not be black smoke which is visible. Pollution may be particulate matter which is not good for our health. Then subsequently, instead of changing the fuel, they started redesigning the hearth. Hearth means wherever they were burning, and the room heating devices. So they began use of coal at domestic level. Formal coal mining was started in 1575 by Sir George Bruce. Now today we talk of coal mine, or you must have heard some 7-8 years ago, coal gate or coal scam. So how important coal has become that in a country the news channels are flooded, but it started here in 1575. Okay, so this is the beginning of coal mining. Then comes first industry. Now these two parts, first and second industrial revolution, you should be able to go through it separately by accessing each and every point, because if you understand this change, how each and every step, what change has come, today you will realize we are not fond of all these things. Today we are at a stage when we talk of cloud computing. So the cloud computing today it is possible because there was some historically some activity took place which was visible machine. Then today it is invisible cloud computing. So there is a chronology. Now what are these? How it affects hand production methods to machine. Now even today skilled workers are praised. Now if skilled worker can be replaced by machine, the industrialists will be very happy because they are going to get product output at a higher rate. Then development of machine tools, everything we cannot do with hand. But whenever you think or read all these things, try to think how these pyramids were made. Because we do not have any record of any machine tools of Egyptian era when pyramids were made. Even today's present crane cannot lift those stone blocks. This is what is the history we are documenting, recent history, but still that part is unknown. We do not know how the pyramids were made. Was it man-made or a machine? If it is man-made, then we need to believe, we are forced to believe that humans of that era were somewhat of different physical stature. Otherwise, it is not possible to lift such large stone blocks. Now, then after this machine tools, new chemicals, iron production process speed up, efficiency of power, water power. Now, this is something very important. Those who are in mechanical engineering or civil engineering, they will come to know of this water power. I'll come to those points. The head loss in a pipe, how head loss became important, the role of a pump in overcoming head loss. So improved efficiency of water power, increased use of steam power, acceleration. Now steam power was made into steam engine in 1765 by James Watt, then from wood and other biofuels to coal. Now see, gradually we are shifting towards coal use at a larger extent. Then locomotive, 1814 by George Stephenson. Michael Faraday's electromagnetism. Now you must think, how come this electromagnetism plays a role in pollution? You will come to know when you study the Tesla's activities. Increasing adoption of steam-powered boats. Earlier boats were were mostly driven by wind. They had that white color or pal, which we call in Hindi. Then they used steam power. Then manufacturing machine tools at a larger scale. Then development of large scale coal mining, which is the primary energy for industry and transportation. Now you see 18th century to 1950s. Its consequence now we are seeing. Now what happened? What made Nikola Tesla, or rather coal mining, to suddenly get a big momentum by the end of 19th century? That is actually Nikola Tesla's invention of alternate current and energy transportation. Now remember, it was or it is not possible to transport direct current. It is possible to transport alternating current. This was the discovery by Nikola Tesla in 1887. Now, those who wants to go further, please do not hesitate to read the life of Nikola Tesla. He used to live in a hotel. Now, one should know what happened those days when people were crazy about invention. He used to live in a hotel because he was not willing to waste his time in daily routine activity, and he was continuously busy with inventions. And his invention was transportation of alternating current. Then once it was finalized or found that alternating current can be transported, then previous all inventions, and which I mentioned in the previous slide, electromagnetism. So creation of electricity, generation of electricity by electromagnetism, which require movement of machine or any object within two magnetic coils. From there onwards, the power generation started, which required steam power, which will move the turbine, and the steam power required coal. So you can see there is a connected history. Then economy of coal-based power plant, it was the cheapest. Rather, till 30 or 40 years ago, coal-based power plants were the cheapest. Today, the scenario is changing because air pollution control regulation is very strict. Earlier, power plants were small. Now, power plants are very big. The unit capacity today is 660 megawatt, single unit plant. Earlier, it was 90 megawatt or 40 megawatt. So what is happening? Large amount of dust, fly ash is emitted. So the cost of control is changing. Then from here onwards, related air and water pollution. So now what I have tried so far is to give you an account of from where human civilization started gradually and arrived at a point where we are able to generate power, which up to which large amount of waste is discharged, and this waste is either hot water, wastewater, or polluted air, particulate matter mostly, or sulfur dioxide in the case of a thermal power plant. Now I'll come to a few different type of issues, then I'll reconnect. This is episodes and accidents. So there are two different topics. One is environmental impact and another is risk assessment. These two should be understood very carefully. Any activity has a risk assessment. If you are staying in a house and you have gas cylinders kept there, people usually buy minimum 2 gas cylinder, one as a substitute. And some people who are more resourceful can afford to have 3 or 4 gas cylinders. Now imagine a situation when you have 3 or 4 cylinders, one gas cylinder, LPG cylinder is in the kitchen and is in operation. Remaining 2 or 3 cylinders, you are keeping it outside or in a different room. Now suppose one of the cylinder catches fire for some reason, some mistake or something happens and one cylinder catches fire. What it will do? It will get fired, explode, and it will put the second cylinder also in fire condition. So what is happening? One accident is leading to second accident, cascading effect. So what is wisdom? Wisdom is keep the 2 cylinders at 2 different places or 2 different rooms. In case one catches fire, the other, I don't say safe, it will not lead to large size explosion or fire or damage. So this condition wherein you have stored chemical or energy at a place, this condition is called hazardous condition. And a priori knowledge about such a condition, its quantification is risk assessment. If you have small children at home, and you must have seen electric plug points are usually maintained at a height of say 1.5 meter or above. Why it is so? The reason, if you keep those electric plug points at say 1 feet near the floor, small children, toddlers, when they start walking, they won't mind inserting their fingers inside those switches or the plug points. So we know there is an electric hazard. If there is electric hazard, how to prevent it? So it was decided or well thought by the initial earlier people, and they decided to keep it at a higher level, 1.5 meter or above. Somewhere at that height, it is safe. The man grows, by the time he grows up to that height, he learns the fears or dangers of electric hazard, and then he keeps a distance from it. So again, here comes the question of understanding hazard. Another example I can state to you, static electricity. I was in a trip to Antarctic, Maitri Station. When I went there, we were told that the entire communication system got burnt out. Now, how it got burnt out? The temperature was negative at that time, minus of 0 degrees Celsius. How it got burnt out? The air in Antarctic is dry. Dry means it is cold. It does not contain moisture. And dry air, when rubbed against molecules or any object, so one of our colleagues, when he was doing some work outside from field activity, he returned to our station. Because of the strong wind, his body got electrically charged. So he developed static electricity in his body. Now, when he came to the station, our station, he used one of those telecommunication devices. He touched it. And when he touched that telecommunication device, the static electricity stored in his body passed through that telecom device, and everything was gone. In an instant, the entire supply, the telecom device got burnt out. So thereafter what we did, they maintained a thick copper cable, buried it deep inside the ground, and whoever comes to the station, their duty was to first hold that copper wire for some time so that the static electricity stored in his clothes or body should be discharged, and then he enters inside the station. So what is done here is assessing the risk. Now, in the beginning, when I mentioned about two examples, methyl isocyanate, MIC gas leaked at Union Carbide India Limited Bhopal plant. Is it an air pollution episode? If you go through the sequence of activities, anyone who is interested in understanding what happened at MIC Union Carbide India Limited Bhopal, you can refer to a book on industrial hazards or disasters by Kharbanda and Stalworthy. You will get account minute by minute what has happened. We had 5 types of safety devices which failed one by one, and finally the toxic gas released. Had those safety devices worked, we would have saved. This casualty would not have happened. Similarly, in the case of styrene, now we need to understand how styrene reacts. If you smell styrene, it's a sweet gas. It gives very sweet odor. But after certain limit, suddenly you will become unconscious. That's what is styrene. It is very, very heavy because its molecular weight is 104. And in last talk, I told you the molecular weight of air is 29. So 104, it will have a tendency to settle down. Styrene is a monomer. When it's used for making plastic, once it settles down, no issue. It will assimilate with the soil. If more number of monomer styrene gas comes to each other, it will form polymer, which is a form of plastic. So it is not dangerous. It will solidify and make a plastic material. So again, there is not a problem. The problem is when two monomer styrene molecules come close to each other, react and form a polymer, it releases heat, and that heat causes the issue at your LG Polymers plant. So it should be kept in a low temperature condition where the polymerization should not have taken place. Then because of polymerization, excess heat, pressure increased, it leaked out and then caused all these damages. So these are all the subjects related to risk assessment, not air pollution. Now, when you talk of risk, what kind of risks are there? Remember an abbreviation CRIT, CRIT. C stands for corrosivity, R for reactivity, I for ignitability, T for toxicity. Now, in the case of methyl isocyanate, it was T, toxicity. In case of this LG polymer styrene gas, it is toxicity. Okay, corrosivity is a different part altogether. Means you need to understand the chemistry of corrosive substances. Then reactive substances where suddenly explosion takes place, and ignitability, LPG gas cylinder is in ignitable I. So CRIT, you remember, you will connect yourself to, you will be able to assess the hazardous condition for risk assessment. Now come to the environmental impact. Now we will come to the part where we are discussing our current talk. If any activity is routine means thermal power plant or a chemical plant or a cement plant, the plants are in existence and government has given permission to operate it. If government has given permission, means the industrialist or the operators are allowed to release some part of pollution, gas, which they cannot contain into the atmosphere. And therefore, it's a routine activity where you know what are the pollutants, you know what is the emission rate. For example, power plant, they are allowed to emit up to 30 milligram per normal meter cube of flue gas. So government is fully aware, and in the ambient air, if the concentration of particulate matter is say 50 microgram per meter cube, no issues, because 60 is the limit. It is less than 60. It is not harmful because the quantities emitted is less than the regulatory level of 60 microgram. So particulate matter will not cause much known injury to us. So that's the point where we study the environmental impact. Okay. Whenever we talk of air pollution, a few cases worldwide are reported. You must have studied London smog episode. Another is Los Angeles smog. There are two words, and I can assure you in future the literature will contain pollution in the northern world, India, the parali burning, stubble burning. That will be the third kind in future we are going to refer. Now we need to let us understand what kind of activity they are. Okay, this diagram, this is a symbol of emission in an industrially developed country like UK or USA, where they discharged or emitted large amount of pollutants from World War I, World War II, or to say up to 1960s, 70s. Thereafter, they shifted their operation to countries where environmental regulations were not very strict, like China, India, not Africa. Why not Africa? Because to operate these facilities, they need raw material, manpower, skilled manpower. India, China is a country or other Asian countries where the skilled manpower is available. So these operations were shifted here. One of the example is methyl isocyanate, UCIL plant. It was brought in India at the outskirts of Bhopal city at that time. So because our environmental regulations are not very strict, now we are operating gradually. We are realizing it after several accidents, that we are also supposed to be very much aware about the environment, pollution. Our rules should be strict and implemented. So that is how gradually we are now finding it difficult to operate these facilities at lower cost, because overall cost includes now the cost of waste treatment also. Now, I'll have written given some of the episodes. Now, remember the word episode, air pollution episode. What's the meaning of episode here? Just read this. Let me drink a glass of water, please. Okay, now I'm ready, back on my seat. London's, I was talking about episode. Episode is the word. Currently in India, we can say Delhi is facing an episodic situation. What is this episodic situation? Suppose, imagine a condition where the stubble burning takes place in Punjab and Haryana in the month of April. Will the pollution level in Delhi be as bad as it is today? No. The reason, today the meteorology is such that it favors accumulation of pollutants it do not allow pollutants to move ahead or up in the atmosphere, and therefore the concentration is building up. This is only for a short duration. And how atmosphere is helping it? Because it is the winter period. During winter, vertical convection is less, ground heating is less, and particularly in northern India, this is the time when the Siberian winds, a part of Siberian wind descends from Himalaya and makes the northern Indian part very cold. And if it is very cold, what it causes? Inversion. Those who will study atmospheric subject in future, modeling part, they will realize what is inversion. Inversion condition wherein as you move above the surface of the earth, the temperature increases. In inversion condition, the spread or dilution of pollution do not take place, and therefore it is called episode. In northern India, whenever this comes, suddenly Honorable Supreme Court intervenes and asks the state governments what action you have taken. In turn, they approach the Central Pollution Control Board. Everyone says one thing, just wait for a few days. Let this inversion layer be broken up. Let the wind speed takes momentum. Let it get at a higher side of the wind scale. Automatically the pollution level will come down. Of course, not below the regulatory level, but it will come down and will cause less pollution to the extent that it will not affect the local citizens and they can continue with their activity. Now here in this case, London 1873-74 winter, then 1934, you see, read the last line, no regulation or reporting system. This was the mistake because episodes are bound to take place. The cyclones that is hitting our country, or rather any continent in the world globally, they learned something from that cyclone and prepare for whenever the next cyclone comes, how to deal with it. In this case, what went wrong was there was no regulatory mechanism wherein these things can be reported and prepared for the forthcoming event. What happened? London smog, December 4, 1952. This is a time when the things got worsened and they started documenting it, and then gradually rules came into picture. When they started making new regulations and rules, then only they found that, okay, now we can reduce the pollution. So if you go here, I think all of you are reading it, I won't repeat it. These are all the sequence, time by time, what has happened at that time in London. And that is why this London smog is very important. In the last 3 weeks of December, some 4,000 people died of smog. And 8,000 died later as a result of respiratory complication. This is what is the London smog issue, which disturbed them. Then, this is what we cannot even imagine today, that merely because an episode of pollution, what has happened, electric power cut off, Heathrow Airport closed, then BBC curtailed its program, and you can see La Traviata Opera closed after first show, birds crashed into building. Now who was benefited? Dry cleaners and beauty shops, crime rate increased. Okay, hereafter, you can see, since this disaster, stricter restrictions have been placed on coal burning furnace. Anti-pollution laws are strongly enforced, and today's London pea soupers have been nearly eliminated. So today what we are trying to do, or governments are trying to say, that in Punjab, Haryana, please do not burn stubble, otherwise it is causing pollution. All our laws related to air pollution are framed once we feel it, because that's the only way we understand how it can affect our life, health, and that's why we frame rules. So when London people they made their rules, we also learned from it, and gradually we are making our own rules. Now, London smog was because of, now please note, London smog was because of the burning of coal. Coal contains sulfur. This is very important to understand. All smogs are not alike. There's difference. London smog was because of coal related and its sulfur. So sulfur results into release of SO2. Coal results into release of CO2, then ash, and then carbon monoxide, because they were using it mostly for room heating. So their oxygen supply was less. So CO was more. Then what has happened? The black smoke and sulfur dioxide, when it was winter, resulted into black color liquid precipitates, which is acidic in nature, and it hurt them. Los Angeles smoke. Here I have shown the diagram, the image of a Los Angeles city under such condition. This was not coal. This was vehicular emission. Now, how vehicular emission and coal can be compared? The chemistry behind it is, when coal was, to say, badnaam, it was ill-famed because of its black color and smoke and sulfur dioxide. People shifted to other fuel types, and very popular was the petroleum product. So diesel, petrol, that came into prominence, and people started liking it. That gave them another shock in Los Angeles. In Los Angeles, they were not using coal, they were using petrol or diesel in their vehicle, but atmospheric condition was somewhat different compared to London. In Los Angeles, it was a sunny day, so large amount of sun rays coming. At the same time, you are releasing large amount of nitrogen oxide into the atmosphere released from the vehicle. Now, nitrogen oxide, actually it is nitric oxide, NO, that comes into the atmosphere, solar insolation, then presence of other volatile organic compounds, they resulted in the formation of ozone. So whenever someone talks about Los Angeles smoke, it was ozone. The very word smog, people, this journalist community, they relate smog as smoke plus fog, but it was good as far as London is concerned. But if it is Los Angeles, it is not fog and smoke. There is actually ozone formation, and ozone, if formed at the lower level of atmosphere, its effects are different. What are its effects? Yeah, this was, you can see, Los Angeles, summer 1955. Now, it is the topographical condition, valley effect near ocean. So the wind was from ocean, but it was not getting drained off. The wind was not getting drained off. There was a dead pocket of air mass. Temperature was high for 1 week. Now here temperature was high. In London smog, temperature was low. Dark haze filled the air as sun rays interacted with the exhaust fumes of car. Now what happened? Actually, it forms formaldehyde. Formaldehyde causes eye irritation. So it resulted into painful eyes and breathing. Then they gradually changed everything, and today they say that, okay, we have shifted from gasoline to CNG and we are safe. Now let me quote one example. In 1996, sometimes We made a study at National Capital Region, Carrying Capacity Based Development Study for National Capital Region, Delhi, and wherein we suggested for Delhi, we have to shift from diesel buses to CNG buses. This will improve the air quality. So those days there was something called blue line buses. They were all diesel buses. As per our recommendation, it shifted from diesel to CNG buses. Today there is no diesel bus in Delhi and all CNG buses. Since then, I am collecting the data and analyzing the air quality of Delhi. Those days I was able to say sulfur dioxide was more, particulate matter was more. Today when I analyze, particulate matter is more because ground is resuspended dust is there, it has not come down. Sulfur dioxide has come down drastically. We can say we are much better as far as SO2 in Delhi is concerned. But ozone has gone very high in Delhi. Nitric oxide has gone very high in Delhi. So shifting from diesel to CNG, it has only resulted in shifting pollutant from SO2 and PM to particulate matter and NOx or ozone. So when we take a decision, we should be prepared to learn the impact of such policy changes. So this is what has happened. Now, this slide I showed you last time is about the definition of air pollution. So I think I should stop here for some time. May I request Adhikari sir to say a few words? Should I go to the next presentation or the time is over because it is almost 1 hour?
Okay, sir, the next topic takes 1 hour. Then I think we should stop today.
Yeah.
Yes, sir.
Okay, so first thing is I am. How should I do? So I am stopping the sharing part.
All right, sir.
All right. Yeah. Now, if you have any questions, you may think that I have not yet come to the control part. It will take time. I need to talk on control. Before that, we need to understand a lot about these words which appears to be peripheral, but without knowing this, if we jump to control, it's of no use. It won't help you. I can give some examples where such controls have failed. Gradually, it will take time. We'll see how to do it. Any questions? Please bring it.
About questions. There is a question came. Can you please, maybe it will be repeat for you. Can you please just explain what is mean by that episode? It's some happenings. It's some collection of facts, gradual facts with time. So can you please explain that one more time?
Okay. I'll come. This word is important. Episode. I can explain it with some social activity, social things. Some event has taken place which is not good in taste. One child was trying to ride a bicycle. Somehow he fell down. Do we stop letting him ride a bicycle again? No. That was an event. Okay, it happened, he fell down. In the nature, there are certain time periods when suddenly the pollution concentration builds up high, much higher because of the atmospheric conditions. And it doesn't happen throughout the year. It's only for 1, 2, 3 days, something of that sort, very short period of time. And then situation comes to normal. Now, such periods, when because of the adverse environmental condition or atmospheric conditions, the concentration of pollutant goes high, we call it episode. It is not routine air pollution. It results in higher concentration of air pollution, but it is an episode. Now, I quote one example. Every year, there's an annual phenomenon of dust blowing from the deserts. So from Rajasthan, the dust cloud comes, it crosses over up to Kanpur. So even in Delhi, you feel very high wind, large amount of dust. But that doesn't continue for the whole year. It is only, and my study shows somewhere until second or third or fourth week of April. Every year it happens. Once in a year, it's a cycle that dust is brought from the western part of the country. Actually, it is not from Rajasthan alone, even from the West Asia, Middle East, Dubai. From there, this dust cloud comes. The wind comes actually. It carries dust cloud and it sweeps through India. So this is an episode. It is not air pollution. During that period, better to keep ourselves safe. Those who are living in Rajasthan, Jodhpur, ask them the dust cloud. We can see I've seen the video, photographs. You can see gradually very huge chunk of dust is traveling. So from a distance, you can see how it is traveling. It is an episode, occasional, not a routine. So I think I am able to tell you what is episode. Next, sir, please.
Next question is, any substance whose particle size, molar mass is comparatively larger than the air, then how it can pollute?
Please repeat the question.
Sir, if any substance whose particle size or molecular weight especially, if that is above or higher than the air molecules, then how it can do an air pollution? It's like it should be kind of precipitated, or it should not be mixed very well. It should not stay for a longer time with air.
Very good, very good. This question is very fundamental and it's very good, one should remember. When you study fluid mechanics, you will study a term called U star. Those who are from civil engineering or mechanical engineering or chemical engineering or studying fluid mechanics, that is the term called U star equals to under root of tau by rho. Okay, now I may be going deeper inside, but its physical meaning I'll explain. If wind is blowing in a direction, if its U star is high, it will not let particle fall down. It will keep it in suspension. That's the significance of this term U star. So any particulate matter, if you put into the air, why it is air pollution? Because it will not get, it offers resistance to the and the wind motion or U star, if it is high, it will keep this particle in suspension. And if it is in suspension, it is polluted because when we breathe air, these particles enter through our nose, and if it is finer, it gets deposited into our lungs. And if these finer particles have chemical properties which can injure our lungs, then certainly it is a pollution. That is why it is a pollution. Large size doesn't mean it will precipitate out. Now, to understand that, we need to understand the size of particles. So there is different definitions to explain what are the size of particles. PM1, PM2.5, PM10, then SPM. What is PM2.5? The aerodynamic diameter of the particle, if less than 2.5 micron, it is PM2.5. If this size has the ability to enter into our respiratory system. PM10, that gets stuck up in our nose, the nasal hair. So more we go towards finer particles, it can affect us. When wind blows from the desert area, it brings a lot of SPM, suspended particulate matter, where the size goes up to 100 micron. So what we do, we cover our face. In the desert area, you see those who go on camel top, they always wear white clothes, and they always have a white scarf. Then my friends call it kukar ka gasket. They keep a band here to keep themselves. Actually, that is they will not breathe in dust particles, and they are living there for generations. So if it is natural dust, its particle size is not very small because the formation of particle is by natural grinding action. But if it is a combustion related particle, now combustion related particles mean you're burning coal or petrol or diesel or kerosene. So from solid or liquid to gaseous conversion, some particles are left. They are very fine particles. So they range up to PM 2.5, PM 10 or so. That causes more injury. That is why we say anthropogenic activity related emissions. That is detrimental to health. So the student's question was, how it is air pollution if size is greater than air? It is polluted because we are concerned with our respiratory system. Along with air, we breathe these particles also. I hope I have partly answered the student.
Another question. Is air pollution mainly a local problem or it can travel long distance?
Okay. I think what student has asked is actually one entire chapter of the air pollution subject. One of the chapters of air pollution is scales of pollution. So scales of pollution, the first point is local, then comes urban, local scale, urban scale, regional scale, continental scale, global scale. So these are different scales of air pollution. Now, I'll give some examples. If you say release of chlorofluorocarbon, earlier refrigerant, if it is released, it causes ozone hole, that causes penetration of this short wavelength solar radiation, resulting into skin burn or skin cancer. So that's a global problem. Release of large amount of greenhouse gases, that causes global warming. It's a global problem. But now let's come to a smaller issue. Suppose in a colony or residential area, some people burn plastic, waste material that is accumulated in their colony. If you burn it, it will affect people living in the vicinity, say 100 meter or so, or it's up to 1 kilometer. That's a local problem. And where it should be reported, such local problem, it should be reported to the local pollution control board or municipal corporation. But when you release chlorofluorocarbon or large amount of greenhouse gas, it should be reported to Paris Convention or IPCC. So the reporting bodies are different. When the scale of pollution increases, the regional scale pollution was when from the London, the sulfur dioxide emitted caused fish kill and forest loss of the Scandinavian countries. So it was shifting from one region to the other. They went to the international court. So UNEP borne out. So the scale of problem is a different subject. Again, the scale of problem, when you study, you should study the wind pattern, the scale of atmospheric motion, because both are related. The scale of atmospheric motion to this air pollution, the activity you are taking place. So this is how it is done. In 1990s, if you can recall, when Saddam Hussein burned the oil wells of Kuwait, the whatever material was emitted, it was found. It resulted in the black rain in Turkey. Now, Turkey is far away. So from Kuwait to Turkey. So it has become two different problem between two different countries. So I hope I'm able to give you some feel of what is the scale of problem. Next, please. Voice is not there.
Manuel, sir, you are muted.
Okay. Right now, students, I can't see any new question from them. So I do have a question.
Yeah, please.
It is often proposed, and which is true definitely, that plants, that air pollution, like too much of CO2 concentration, as we know, plants, trees, they used to take CO2 for photosynthesis and other thing. So is it true, or I will say, is it possible right now, if we just stop, if you are stopping deforestation and no new kind of civilization or something like that. So if we stop right now, the place left for forest, for greenery, that will be sufficient to maintain kind of the pollution. I should not say maintain the pollution, to stop or the pause the pollution level right. Or my question, maybe I can't express it. It's like, is it true that whatever the land left, and if we plant trees, that will like truly help it, or that will be too little with respect to the emissions of this modern?
Okay, good question, and this answer to this question will lead to more arguments and controversies. My way of thinking is something like that. Let me respond to you. When you put a question that by putting more forest, or to say stopping the deforestation, can we reduce the pollution? Now, at this point, you have assumed that if we stop cutting the trees and stop deforestation, the pollution will come down. It is your assumption. Okay, let me give you more example, live example. Last month or few months ago, there was a big forest fire in California. Okay, the cause of fire, they have very large size jungle forest. Now think green forest, large in size. Today I talked of accidents, hazard. Can you for a while imagine that if lightning strikes and a part of the forest tree gets burned, it causes spread of fire into the nearby jungle. Will it not lead to pollution? Or if we think from the risk assessment point of view, will you not think that I should have I should limit the size of forest to the extent that if it catches fire, I can control it? What happened in Los Angeles, or rather regularly happening, at one end, we are asking people not to burn waste kachra. On the other hand, when the forest catches fire, a large machinery is employed to remove large number of trees, to fell down, so that the fire from one tree to other tree should not spread. So a large tract is immediately cut and removed. Now that is an accident, agreed. But can we control by saying that no, our forest area should be of this size? If it goes beyond this, if it catch fire, our intervention will fail. Then we will have to wait for the natural cooling phenomena when this fire will douse off. So this is one example I have quoted to respond to your initial thought that merely planting tree will reduce pollution. Now, imagine a situation, CO2 buildup takes place. Why we need plants? Because plant will convert by photosynthesis CO2 into oxygen. We are satisfied, comfortable with that thought line. Imagine a situation, atmosphere is having larger CO2. Now, in this direction, actually, thoughts have not gone very high. Means the research is still going on. What will happen if you have studied Henry's law of partial pressure? What is Henry's law of partial pressure? If there is a water layer, there's a water media, okay, there's a atmosphere or any gas. The transfer of gas from the upper gaseous media to water takes place in proportion to its concentration. So in air, if CO2 concentration goes high, what may happen is the same proportion, its concentration will be, the part will be shifted into the water, and this water is actually ocean. Now, if it goes into the ocean, what will happen? I'll come to that part little later. Which, this question was asked recently, which part of this ecosystem produces more oxygen in this? So I'll give you an option. One is plant, tree, green tree, terrestrial. Another is blue-green algae in the ocean. So a general belief is these trees produce more oxygen, but that is not correct. Oxygen is produced much more than this terrestrial ecosystem by the ocean phytoplanktons. So if CO2 builds up, what will happen? It may get transferred into the ocean water. There, the unicellular microorganism, algae will convert it, release more oxygen, more number of algae, more number of fishes, more number of whale, it will do more fishing. So all these cause and effect relationship, we have not yet fully understood. Instead, what we have made rules, कि पेड़ नहीं काटना है. Agreed, it gives a good scenery, we enjoy, I also prefer. But for survival, if you want to make a house and you have to cut a tree, you have to do it. So this line of thinking where you're going, always keep ocean also in the picture. Then it will be a bit easy. Yeah, practicality is different. Siddhant alag hai, vyavaharikta alag hai. Sir, anything else, please?
No, sir, that was pretty good. Thank you so much. I think our... Yes, sir, please.
Sir.
Thank you, sir, for your nice talk. In fact, today we had the duty in the campus, but at 3 o'clock we started and came back to house to listen to your lecture without any disturbance. So that's why we are able to, myself and Sabil, we rushed to catch the bus at 3 o'clock, sir. Nice, sir. It's a really nice talk. Sir, if possible, we can have one more lecture also regarding air pollution aspects.
No issue, sir. This kind of Saturday, actually, I was supposed to go to Ahmedabad on 25th. I booked my ticket, but because of state government's new regulation that all those who are coming back from other states, they have to undergo some tests 2 to 4 days in advance. Then I had no option than to cancel. That's why I'm here today. Otherwise, I was supposed to cancel today's talk. So whenever time comes, I'll give a talk. Yes, and anything specific of your interest, I'll do. But I prefer to move in a gradual way because I know there are a lot of gaps which needs to be filled first. Our syllabus is made in such a way to directly jump to some higher end topics for which we are not actually prepared. So I'm trying to prepare that basic ground.
Yes, sir. Actually, the syllabus, as you told, it is nothing but the building only. We don't have the foundation. I think you created foundation, sir.
That's important.
Yes, sir. In this lecture, I am having only one small question, sir. You told episode, sir, as an example. Can we say the hurricanes and the flooding and tsunami like this episodes?
Yes, it is episode, but when it becomes daily phenomena, it's no more episode. It is an episode, natural episodes. Even this large amount of sudden rain, cloud burst, that is an episode. Or leading to accident, episode leading to accident. then lightning striking. It's an episode we cannot predict. Now our satellite observation is helping us to predict these cyclones, because now we are in a position where are able to locate, and we are able to locate the eye of the storm, and then from where, how far it is going to hit us. So that's how we are up to that level.
Sir, one more question. Yes, sir.
Sir.
Sir, the pollution tolerance varies from person to person, sir. How we can interpret that one, sir? For example, people living in hill stations, they can tolerate this low oxygen, sir, because that natural condition like this,
sir. About this particular issue, hill station, it's easy to explain. One example I can quote: in Kerala, most of the athletes are from Idukki. Idukki is a hilly area. So those who live in hilly area, if they are there since childhood, their lungs develop in such a way that they can sustain much more, their stamina is high in terms of oxygen carrying related to those who are at the shore. Now, I experienced it in one of my pre-training to acclimatization tour before Antarctic. We were taken to Auli. Auli is a skiing resort, and we were put up in a ITBP training center. So when our bus reached there, and why we were taken there, we were asked to be there for 3 days, and then we were taken to next station, that is Badrinath, that famous Badrinath temple. Near that, there is one Mana Glacier. We went up to that. So when we reached Auli station, ITBP, we came out of our bus, took our luggage, and went inside our room, made a change, and then I realized, now let me enjoy. I came running out of the that guest house and started running, but after 3 steps, I had to stop. I was not able to go ahead. I was breathless. The reason, then I realized I am not in central India, I'm not in plain, I'm in hilly area. Whereas people, those who were living there, they were moving very fast. And it really took 3 days for me to be normal there in Uttarakhand, Auli area. This is somewhere close to near Joshimath. So it's a very famous skiing resort. So as you said, it's correct. The geographic location, altitude, that changes your capacity. More studies are there. African people, why most of the marathon runners are from Africa, Kenya, Nigeria. Their muscle fiber is in such a way that they have very large stamina. Means they can run for 2 hours, 3 hours. So it is their lungs as well as muscle fiber. All these studies are well documented. So for those who live in different part of the world, they have different abilities. So I think I have partly responded to your query. Sir.
Sir, one last question. I think that's a very good question. That's why we'll go for that. The Australian forest fire is necessary cause for the ecosystem of the species in Australia, but the pollution caused from it does not appeal for the safety. That's the question. Like, is it that's happening that they're burning, or this thing is actually helping for maintaining the ecosystem? Whereas the pollution part, do you have any idea about that, how these two got balanced there?
Okay, good. Means the questions are now emerging in a higher level. We need not go to Australia to understand. Let us understand Punjab stubble burning. Okay. This problem was not there 10 years ago, but 10 years ago they were burning for their stubble. It means what has changed? This particular period, if they do stubble burning in some other period, it will not affect us. So stubble burning was practiced there historically. Now, let's understand why stubble burning is, I cannot say in an open forum it is necessary, being a person of this subject. But let me explain what are all the possibilities. When you burn stubble, you return the carbon from fiber or lignin to its form, which is easily available to the next plant, next crop, by burning stubble. That is one. It releases sufficient nutrients faster. The nutrient release cycle is fast if you burn it. They don't burn it to the level where it goes as red hot. They burn it only to the level where it is black. Then another issue. When you raise the temperature of ground, you kill certain microorganisms, which can become pests for next crop. Have you ever thought of this? It kills pests for the next crop. So the next crop's yield will be good. One of the examples, you can understand biodiversity of a desert ecosystem and a rainforest. So rainforest I'll compare with Kerala rainforest, another say Rajasthan. In Rajasthan, the temperature fluctuation is 0 to 50 degrees Celsius. In summer, it can reach up to 50, and at night, it can come down to 0. For this wide variation of temperature, only a limited hard species can survive. Whereas if you go to a rainforest, whatever shall be the solar insolation, we may feel hot, humid, but moisture is there, which controls the temperature variation, because moisture acts as a thermostat. It takes up heat, evaporates, if it cools down, it settles. So moisture makes that balance. There, large number of species can survive. So here, what is happening in a suddenly, another example. Imagine for a situation in 1 year, there is no summer. Suppose there is no summer. I can assure you that year's crop will be gone, because this summer raises the temperature to such an extent that a large number of species, microbes, which may become subsequently pests, that will be removed. So summer is important in the cycle. So when they talk of Australian fire, that's actually plant fire. Now, when it becomes air pollution, when someone complains, if I don't have a complaint, what you're firing, no issue.
Yes, sir. That is very true. All right, sir. Thank you so much for that explanatory. Trust me, I can remember when I first joined VITAP. In my career, first time I taught EVS. I had some information, but mostly from a scientist's view, a chemist's view. So that semester, I studied a little bit. I have to, because I have to give students. But I can definitely tell that if I teach EVS now, I will have a different approach. And these two lectures by you literally, like how basics are very much related with these modern things. It's like someone is saying CO2 emission, like you say, tree plantation. Never, I think, first time to me that sea has that much contribution for absorbing CO2, and it's more than tree. So these things, so really we appreciate your lectures. And now I will go to Somakant Kusti sir. So please.
I want to add one word here in response to what you said. See, if we go by scientific and quantitative thinking, one may come to the conclusion that some trees need to be cut, some forest needs to be fired. But if you teach this to general masses, what they will do, they will pick up the and start firing. And that is why, even in regulatory level, we say, no, mat kato. Don't cut trees, don't put it on fire. Because these are the loopholes where people take advantage and misuse it, which we want to avoid. That's all. Yes, sir, please.
Somukandi sir.
Sir, thank you very much for giving those great lectures, and our students are certainly benefited of this one. So on behalf of Department of Chemistry, I sincerely thank you for accepting our invitation and giving the lectures. Thank you very much. We are really very happy to have you as a guest lecturer in our EVS lecture series. Thank you very much, sir.
Thank you, sir. Thank you very much.
Just like to
Thank you,
add,
sir.
Somakandi sir, can you please stop the live part so that we can have our kind of short session with Dr. George? So
Yes, sir. Yes.
can you please stop the live session?